So welcome to the August 2024 SNOC Soils Network of Knowledge webinar. I'd like to start by acknowledging the traditional custodians of the soils and lands on which we are, wherever you may be in Australia, and show my respect to elders past and present, and thank them for teaching us about being one with the land. So welcome to the August 2024 Soils webinar, Thinking About a Soil Carbon Project. Understand Your Soil Data First, by Karl Anderson with New South Wales DPIRD and Brian Murphy from the Soils Knowledge Network, brought to you by the New South Wales DPIRD Soils Unit and the Southern New South Wales Innovation Hub. My name's Luke Benge and I'm a Soils Development Officer with New South Wales DPIRD or DPIRD and a Regional Soil Coordinator with the Southern New South Wales Innovation Hub. And I'm backed up very ably today by my colleague Blake Palmer, who shares those roles with me.
Thank you, Luke. I'm from Soil CRC, Felicity Harrop, the Soil Knowledge Broker, and I'd like to welcome you all to the second of 7 webinars presented by the Soil CRC, supported by New South Wales Government as part of the Primary Industries Productivity and Abatement Program. PIPAP is providing information to land managers about carbon farming to help them make evidence-based decisions. At the first webinar, we heard how visualising Australasian soils and New South Wales data in eSpade provides spatial soil and land characteristics to assist with soil carbon planning. Today, our presenters will cover the interpretation of soil data and land capability for considering a soil carbon project, including the factors above and below the ground impacting soil carbon, interpreting soil data to assess land suitability for increasing soil carbon, and identifying opportunities for additional land management practices to optimise soil carbon. The next 5 webinars will be hosted by New South Wales grower groups and will cover specific land management activities suited to their local environment and meet the eligibility criteria for a soil carbon project. So keep an eye out on the Soil CRC and grower group websites and social media for registration details. Today, I'd like to introduce Dr. Karl Anderson, Research Officer, Soil Carbon Officer for New South Wales DPIRD. A soil scientist with 25 years experience throughout New South Wales, Karl has worked in regions from the high rainfall to the semi-arid zones in fields including soil mapping, agronomy, soil carbon, nutrient cycling, irrigation and dryland and urban development. Karl is based at Tamworth Agricultural Institute and works to enhance soil management practices within the New South Wales agriculture sector and is an experienced researcher and communicator of soil carbon information. We also have Dr. Brian Murphy from the Soil Knowledge Network. Brian has worked as a soil scientist for 30 years with a strong focus on applied science. His work involves providing day-to-day advice on the management of soils for a range of natural resource issues. He's worked on the measurement and management of soil organic carbon in agricultural systems and published several scientific reports, papers and extension articles on this topic. He's also an editor of a very successful, widely used textbook, now it's in its 3rd edition, on the characterisation and management of soils. Brian will assist with answering questions at the end. If we just have a look at the second slide, please, Luke.
No worries. Just had a little report, sorry, Felicity, that some people are having trouble getting in, so I'm just, I might ask Blake if he might look into that for a sec, but we'll go to your next slide.
Yeah, so as I said, the future webinars will focus on new management practices, soil carbon, local farming systems, soil specifics, and they'll be delivered by Soil CRC participants, researchers and industry. And you can see Holbrook Landcare, Riverine Plains, Mallee Sustainable Farming, Central West Farming Systems and FarmLink will be involved in delivering those webinars over the coming months. So like I said, keep an eye on Soil CRC events page and the grower group events page. Thanks, Luke. I'll hand it over to Karl.
Thanks, Felicity. Yeah, we've got 77 people in here, but we do have a few people from outside who are having trouble getting in. I might talk to you offline about that, Blake, but in the meantime, I will just change the presenter to make it Karl Anderson. You should get your message, Karl. Here it comes now. I'll let you know when we can see your screen. Yep. Go for it, Karl.
Right, thank you, Luke. So the purpose of today's talk is really aimed at producers and their advisors, considering what you can do to manage soil carbon, not specifically how to increase it in one or all areas, but to be informed about the processes in soil and what you can expect of the dynamics to result in a change, and considering any sort of involvement in carbon trading schemes. The outline is to look at soils in the landscape, interpret what you've got in front of you and under you. Consider the processes that influence soil carbon. Then looking at some data and data that you might be able to access or do have that you could use to ballpark your soils, and then consider steps for a soil carbon project. So firstly, what is it? What are we talking about? Soil organic matter is basically the stuff that's come in through plants, processed through animals and microbes. It's brown or black. It's dark in the soil. We can see it. It provides lots of great attributes to the soil, turns it from dirt into soil, and it's basically what you want. Carbon, the soil organic carbon, is the carbon part of that matter. We measure that in the lab, usually given as a % of the soil mass. And it gets respired. As it gets respired, nutrients are cycled out of the organic matter. Bulk density is a term that says how much soil there actually is in a given depth, say per hectare, and combining carbon % and how much soil there is gives us a carbon stock, how much carbon you have in that hectare per depth, say. And if you're in trading schemes, that's what they want. The equivalent soil mass is if you're thinking of sampling between one time and the next, you want to get the same amount of soil so that you're not inflating or undercutting the amount that you have been estimating. And then carbon fractions or pools is something you might hear, which is basically talking about the decomposition of the organic material. Terms like particulate, labile, humus, mineral associated, pyrogenic or charcoal, those sorts of things just represent where organic matter and carbon is moving through. So some context about what we're talking about. I'm going to have a series of profiles from different places and see what they show. So what we've got here is two soils from different parent materials in high rainfall area, basalt on the left and a granite on the right. Basalt's from Batlow and granite up past Tumbarumba. We can see that there's a concentration of dark material in the surface. That's our organic matter. It fades away as we go down, and in the basalt on the left there, it's gradually depleting as we're getting more of the more sort of just clay and redness, which is the iron in that soil, coming through. Quite a different soil developed on the granite. There's more sand in it. Over time, the sand sort of shaped to the top and the clay shaped to the bottom, and we get this difference of sort of sand over clay. And that helps that organic layer stick out so much more, very distinct. In this sort of soil, the water comes in, hits the clay, parks a bit, and starts dissolving things and ends up leaching them away. So we end up with this pale layer. Now, organic material is dark. Where it's not dark, it's over to iron for our color. And if iron's gone, then pretty much everything's gone. And this is a fairly infertile material. So long as we've got this on top, the job's right. How quickly can those changes happen in the landscape? Very quickly. We can step over some of these changes sometimes. You can see that in this paddock here. You might see granites as basalt caps sometimes in your landscapes. Take that same granite material and move it from Tumbarumba up in the highlands, coming through Wagga, and then out towards sort of Mount Hope pushing into the western rangelands. Same granite material, very different profile development with rainfall. The Wagga one has still got a dark material on top and a bit of a pale layer there, and a shallower soil as well for the same sort of place in the landscape. The one out west, much lower rainfall, doesn't have that pale layer at all and doesn't really have the organic stuff at the top either. So different soils giving different properties. Thinking about how you relate this back to when you have some numbers, what you're sort of seeing, what they can tell you. An example of running down a hill, shallow soils at the top, up here, not much to grow with. As we go down, we get deeper soils. We've got something more to work with for roots to get into, water and nutrients, storage and access. Getting down the bottom, we might have an accumulation of organic matter at the top where, with more moisture being supplied in those areas. Again, changes of soil type just down the slope. Think about how your numbers might relate to this. These sorts of changes don't just occur on hill slopes, of course, they occur on alluvial areas as well. We can have these stream channels depositing material as they flood and overflow their banks. The sands are heavy and they get dropped out first. As you move away from the channel, the finer sands and silts and some clays get dropped out in these red soils here on the meander plain area. And then further out back where the really fine material gets carried and then left behind as the water evaporates, we get these heavy clays. Again, we can see in this picture on the right-hand side here how those changes happen away from the channel. And we've got little island relics of previous building of this landscape. So lots of changes can happen. So that's sort of some context about how to interpret numbers and how you can look at your data. So moving into the processes that influence soil carbon. I've referred earlier to some of the pools in the soil, and what they sort of give us is indications of processing. The particulate material is labile or relatively easily accessed and decomposed. As we get into the soil, we've got a structured soil, say, that provides some sort of physical protection where roots and organic matter can sort of hide away. As the organic material gets processed, it ends up with sort of active charges on the side of it, which can mean that it can then stick to other charged surfaces in the soil, like clays or oxides, which provides a measure of chemical protection from degradation. The source of it all, of course, is photosynthesis, carbon dioxide being brought in through the plant, which ends up as litter or cycled through manures, the root biomass in the soil, and the all-important exudates. Gets cycled through organisms into soil organic matter, but a lot of it, of course, gets cycled back out as respiration. The more disturbance that we have in a system, the more air gets into the soil for the organisms to respire with. So that increases the respiration of carbon. We have product removal, of course, and hopefully not too much erosion, losses off the soil. We can see erosion though, and the key point about this is, if you're thinking of building, well, first you've got to maintain. And we can see the little undulations, the convex and concave sort of slopes in this paddock where, thinking back earlier to the colours running down a profile, we've got the darker surface soil, the topsoil being sort of washed down into these little these sort of hollows here and being stripped off the steeper bits. It gets sort of moved out of the system in the end sometimes. Similar idea out west in the rangelands, where Tongway and Hindley's idea was about, is a system accumulating resources or losing resources? And out in the drier areas, of course, rainfall becomes so much more important, and capturing it in the system rather than losing it and the resources with it is really important. Some cropping examples where we've got the surface protection of stubbles from wind erosion. John Lees took this neat photo showing how dust is kicking up at the edge of the stubble effect, and then the top one here with bare soils being exposed to summer storms really rips it away. And of course, sometimes erosion is all too easy to see. So what happens below ground? What sort of processes are going on down there? Well, root growth is concentrated mainly at the surface, and deeper roots tend to grow through pores mainly of previous roots or channels being built by soil organisms. Just because soil is heavy, getting down there, it's hard to push around, so you find a lot of it in channels. Rainfall has an effect not just at the surface with that plant growth, but what happens in the soil. So we've got a difference of sort of drought accumulation and mineralisation happening. The microbes respond quickly to moisture and are active at lower water concentrations in soil than our plants. And with Australia having the most variable rainfall in the world, it really means that we've got this stop-start system a lot, where plant can sort of grow a bit and accumulate, but then bugs can attack it. But this idea of sort of drought mineralisation is where you might think that in a drought there's not much input, but if the bugs are parked as well, we can have an accumulation of organic matter towards the end of a drought, and then the drought breaks, then the bugs kick into gear and drop it down, mineralise it out. That's one of the reasons in agronomic sense we don't test straight after a drought, because we get overinflated P and S type measurements which are coming out of the organic matter. So what helps us retain organic matter longer in soils? I referred earlier to the mineral and the physical protection. We've also got the importance of nutrients and the cycling. So carbon levels are related to nitrogen, phosphorus and sulfur in soil being part of organic matter. And we find that fairly consistent ratios in the stable sort of pools. And having a good supply of nutrients in the soil actually helps hold on to carbon for longer. Excuse me. Depth is also an important factor. And generally we find that the carbon at depth in the soil is much older. So the idea becomes, well, if we can get more material down there, then that will stay there for longer. What influences shorter residence time in soils? The idea of priming, which is like activating processes. Fresh organic matter and nutrients can be a source of substrate for organisms, so that can kick into gear and start decomposing. We can look at ameliorating constraints to plant growth, which means more input, but it can also allow bugs to get active again. So it's been found where sometimes where lime's put on, that's overcome a constraint for the bugs and end up with lower organic matter sometimes. Exudates, all important. So much going on with exudates into the soil. Some of those actually can liberate what we thought might have been protected. The mineral associated organic matter there, where the material was stuck onto the soil, but that can actually now be released and mineralized by plants. And there's some really cool stuff with relatively recently found with iron, where some of the reactions can inorganically, so independent of microbes, start to break down organic matter, which sort of puts a bit of a limit on how far we can get with the material. The flip side of the depth story is that material that's there that's older, like you could measure something where the carbon at depth is like 4,000 years old. But what that can mean is actually that it's taken 4,000 years to get there, and all we've got is say 0.5%. So not much actually gets there. Not only can the fresh organic matter that gets put down there be decomposed, but the flush of nutrients or energy that it provides has been seen to sometimes actually get the bugs going, and they decompose not only that fresh stuff, but the soil material that was already there. So all these interesting cycles that are going on. What does carbon look like at depth in the soil? Here's some charcoal in this top left. And now we've got one here where you can see the old surface down the bottom, where the top 20 odd centimetres of material has been deposited from upslope. But what we're really talking about at carbon at depth in the soil, from this sort of management point of view maybe, is looking at these sorts of patterns here, where we've got a root material. You can see that it's decomposed into this darker material there, and it still sort of provides a channel for more recent roots to come through. Here's quite an extensive accumulation of material in this soil here. So these photos I've got for carbon at depth they're in the sort of minority, and what you can see is that with this accumulation, it stands out because there's not much around it. So there's a generally a lower level of carbon at depth in the soil compared to the surface. There's some of those processes, context and processes. Now, so we're at the position of having some data available, and how do we sort of ballpark ourselves amongst that? These two profiles here that we saw earlier, the carbon levels in those in the 0 to 10 centimetres, we can see there 3% in the higher rainfall area with the darker soil, and only 1% down at Wagga. Into the 10 to 20 centimetres, both soils, they're dropping down in how much organic matter is in their soil. It's a typical sort of pattern that we find. with the decreasing carbon with depth. Here's a study from the Hunter Valley, 2,800 hectares with various parent materials and quite a range in elevation of 120 metres from hill slopes and ridges to valley floors. Concentration of carbon at the surface and decreasing with depth. All those black dots are the many holes that they dug, but the median value is the red line here, fading away. Bulk density, mentioned before, that tends to increase with depth. Light and sort of fluffy at the surface and increasing sort of, with just massive soil. We're getting up to these sort of 1.5, 1.67 levels. Generally, your bulk density would be between, say, 0.8 to 1.5 would be a normal range. A bunch lower here. These ones sort of pushing above 2 are very high, very high. Anyway, that's a sort of normal range. And bulk density doesn't tend to change as much in your soil as carbon, unless you're in there disturbing it or compacting it. Carbon would change more so than bulk density. Combining those two, we get the carbon stock in the soil. Again, reflecting the organic carbon percent, but sort of moderating that a little, sort of a bit more compacted. What that's ended up like in this study was this here, where we've got the range from low carbon stock to high carbon stock in the surface, 10 centimetres, and you can see the patterns here where you've got low levels on the ridge tops and higher in the valley floors, like here. So I'm thinking about that stuff we were just showing earlier. Some of these lighter red areas are also places that were sandy. Light parent materials, so sands don't hold onto organic matter and carbon as much as clays. Some patterns of profiles from further out west. At Cobar here, we've got some concentration at the surface, tailing away with depth, but not as high, so 0.8, not as high a number as we have further west. And then going further west, east, going further west and south, much lower levels again, so 0.3 and dropping down. And these funny patterns here, increasing with depth, might be artifacts of some of the funny things that happen in soils out west with inorganic carbon stocks. So an idea of the types of range of carbon percents that we see, carbon stocks that we see in soils. You might have your own numbers, or maybe part of a group who can share numbers to have a look at. And here's a group that we had up in the tablelands, or the tablelands, where we've got 40 odd paddocks there assessed, and ranges from down below, so around 1%, 1.2% in this orange bar, moving up through, pushing towards 2% now, but getting to 3, up to 5s, and then a bit of a bell ringer here. I've included that one just to sort of point out that when you're taking samples, it's really important what you collect. This one happened to have a whole heap of litter and kangaroo poo in it, so send it off to the lab, it's going to be high. So careful about what you sample and what you're looking at. These soils were taken from a range of soils from granite and sedimentary trapped materials and basalts, and they were basically reflecting granites, trap and basalts in those. Take those parent materials and move to Ebor on the escarpment where it's colder and wetter, and those numbers of 1, 3, 5% become 2, 2, 5, and 8, 9, 10%. Effective climate really increasing the level of organic matter in the soil. Go down to Tamworth, and our numbers are lower again. A bit hotter, a bit drier, and we can see less. So we've got again our 0 to 10 and 10 to 20 centimetre samples, and we can look at those and have a bit of a check. These ones here where there's more underneath than there is on top. Again, be careful about what you're sampling. Maybe there's some mislabeling of bags, and if they're legit, then they're interesting, worth checking out. So from this sort of stuff, could you say that, well, these ones here at 1.5%, they should be 2.5% or more? Well, you got to think about stuff we've talked about with what are they on and whereabouts are they in the landscape. Put yourself into context and see what those things sort of tell you. in a broader sense, we took a lot of samples down south in the Riverina here, and not we took. This was producers taking these, and what we've got here is in the 0 to 10 centimetre increment. The colours are showing reds of low moving to green and brown and black, sort of showing what the condition, what the soil colour looks like. Lots of variability within there, but some of the patterns we see is where there's irrigation out here, there's higher amounts, and some of these areas out here with irrigation. In lighter country, there's low numbers. Where there'd been a bushfire had gone through, there's lower numbers. But in general, what we're getting is to the south and west, south and east, as we're getting higher and wetter and cooler, the amount of carbon is increasing as we go there. In the 10 to 20 centimetres, most of that's not there. Yeah, it holds with the profiles that we saw earlier. There are cases where there's higher numbers at depth, which is worth checking, and then interesting to look at. But generally, a lot of that is disappearing, mainly concentrated in the surface. So, how does carbon behave in the soil? Historically there's been a general pattern of losses, decreases of our organic matter and carbon with this sort of pattern. The 0 to 10 is in the top here. There's a rapid drop with time since cultivation, or years of cultivation, and it starts to flatten out. Similar in the subsurface, we've got a drop and then it flattens out as well. Just that idea of microbial processing, more aeration in there, they can process more. There's also part of this would have been erosion losses as well. Similar again, another study long term looking at patterns there, mainly clay soils here, dropping away in a similar sort of way. And what went with that was decreasing productivity. So we can think about carbon for just accumulation, but it's also a key part of productivity, and keeping an eye on this is, we're obviously not wanting that to happen. So that's a thing to be managing. So we get losses and we get recovery. There's a lot of studies showing recovery in systems around the world and throughout Australia with these sorts of rates. Half a tonne, 1 tonne, 1.2, 0.2, those sorts of numbers over periods of 5 to 8 and 20, 40 years. One little update to this one is that the study here around in the Central West near Cowra, in 6 of those 8 studies sites, they've dropped back down in the subsequent sampling just recently. So there's cycling that happens. The ones that retained were one with a really low grazing pressure, and the second one with a whole heap of pea being thrown at legumes, maintained its level. So the key thing then becomes sustaining a recovery. So we can get an increase with more inputs or less outputs, but having that stabilise and sustain is the important thing. So we increase our organic matter, but we've got to keep that organic matter coming, because the bugs will keep going. So to increase, we need to keep that happening. These 2 plots here are showing data from really long-term trials in UK, Rothamsted, you may have heard of, where we've got a bit of control running along the bottom here in our top graph, just sort of sitting there. We had applications of manures which were then ceased, and it started to drop back down. It increased, but then it started to drop back down, still higher. The condition of the soil was improved. Not all disappeared, but where organic matter has been continued to be applied, increasing further, but the majority of it still gets mineralised. It starts to approach a ceiling. Similar sort of story down in the bottom graph here, where we're starting on a cropped site. It sort of bumped along the bottom, increasing a pasture. The amount and the consistency of production and the decrease in disturbance saw an increase in carbon levels. Vice versa on the pasture, where it was maintained, it's poking along, but where disturbance and intermittent growth has been put in with cropping, it's dropped away down to that lower level. So the idea then is that the processes or increases don't happen indefinitely, and in Australia they don't always just happen as easily either. There's limitations of rainfall and nutrients and the initial carbon stock as well. How close to the ceiling are we? Now, if we're not getting an increase, that's actually not a bad thing. It's actually a good thing, because it's showing that the system is working, the system is dynamic, and the soil is functioning. So, you know, as long as you're not at a bad level, I might show you something later on that, then cycling is good. The nutrients, I've mentioned carbon, nitrogen, phosphorus, sulfur earlier. Here's some work from Ginninderra over a 20-year period where applying P was able to increase, and not just in the surface, increase the carbon stock through depth down to 60 centimetres, at around half a tonne a hectare a year. I think it's got up to about 12 tonnes in the end. So the importance of fertility in our systems. Here's some work from Ginninderra is near the AC near Canberra. Here's some work from Cumdoblin in the central west of New South Wales, where over time different rotations were being implemented, and carbon was one of the things being assessed. We've got increasing carbon levels over this 13-year period, which is great in all the rotations. Continuous crop, cultivation, permanent pasture, reduced till, increasing there, and and it was even starting to bump into the 10 to 30 centimetre layer. Same treatments there, of course, but it didn't sustain. Dropped down in both. Dropped down to sort of at or below where they were from 2012 to 15. Was that due to it rained and bugs got active? There was activity for them to start mineralising. Not quite fully explained, but we get this idea of that you're operating within an envelope. There's inputs and there's outputs, and as long as you're on a good path and a climbing plane, say, hopefully, then that's good. But it's not just a one-way story. Grazing management's often seen as a way to be increasing soil carbon levels. Sarah McDonald led a review published last year, looking at 30 papers where grazing trials and carbon levels were measured in Australia, and overall they found that there was no significant impact from the different practices. Now, that's not to say that grazing management doesn't influence soil and productivity and the drivers of soil organic matter. More plant growth, herbage mass, ground cover, residual biomass, and productive perennials, all found as effects, but no change consistently to the soil organic matter. And again, that's not necessarily a bad thing. It's a sign of a functioning soil. Where could our opportunities be? So John Gray's got this work with others looking at the opportunities through New South Wales, where the process was to look at a 10% increase in long-term vegetation, whether that was re-veg, grazing management, or stubble management, and the results come out with sort of low increases expected out west, whereas dry, the sorts of reasons we've been talking about. Patchy influences you can see through the area, low again where there might be high stocks already, but potential to increase in some of these areas like the Liverpool Range or the basalts out of Glen Innes and running down the McIntyre, those sorts of areas. So these sorts of things can be really useful in helping identify areas of the greatest potential to increase soil carbon levels. So with all that in mind, the position of considering a soil carbon project, sorry, Luke, I've gone on a bit. So the first step you'd be looking at is estimating the amount of carbon in your soil, ballparking the potential of where you might be able to get to, definitely managing constraints, and thinking about what changes you could make, what's eligible, what would fit for you, And then what you do with any credits? Would you sell them to someone else to offset their emissions, in which case they're not yours anymore, or would you keep them to inset them against the demands coming from the market and the supply chain? In terms of addressing constraints, here we've got a really compacted soil, really hard, a lot of time for roots to get established in that and grow around. So making that a more amenable environment for plants is a thing to address. Acidity, we've got a patchy lucerne stand here. We can see these signs sometimes, and that's shown in this really trimming off of the roots. Organic carbon here in the yellow, a bit of accumulation in the surface and running down, but low levels there. And the limitation here was acidity with aluminium, really toxic at that layer. So addressing that would help better plant growth, better cycling and inputs. Having a surface soil like this is not real nice for plants to try to get into. So dealing with that type of condition is doable. You can assess it yourself, and getting onto that is definitely a thing to do. Another thing of soil stability is this idea of slaking, and you can assess this by putting some soil into water, and you can see that the darker one, it's organic, it's staying together, and the one that's lower in organic material is falling apart. And I mentioned before that, like, what's a good layer? A good amount of organic matter is where it's staying together. Salinity is something that we could look at managing, especially out west, where there's natural levels of salinity. At this spot, we're basically looking at seawater. But if we could move that down the profile, then plants can get established, and we can start to get some more, not just productivity, but maybe some increase in carbon in our soil. So where does the system let you in? Here are the list of practices that are eligible under the ACCU scheme, and big table. Basically, they fall into these things we've been talking about by and large. Ameliorating your soil. Irrigation's one where you put more water on, more plant growth. Managing pastures, managing cropping, engineering the soil, whether that's land forming or delving, say, or getting legumes and cover cropping into the system. All eligible activities for a change to measure pre and post carbon stocks. Going down that way, there's commitments involved, and you'd be thinking to yourself and talking to others. Like the documentation around this is hundreds of pages long, and there's lots of calculations. So you're definitely having advice and talking to service providers about what's involved. What commitment is required from you to practices, sort of time frame, where does the risk sit, and what options do you have if you decide that doesn't work for you in the end? Would they be helping you take some preliminary measurements to help understand where you're actually at? Do the statements maybe sound too good to be true? Are they offering guarantees? Are they suggesting an infinite capacity for putting carbon in your soil? Are they saying that just changing practice is easy? Do they dismiss any signs, just saying it's BS? All of these things I've heard in public forums. How much extra biomass is actually required to get more carbon in the soil? How long would it persist? Is there new biology that could be an answer? Basically, what evidence is there? Are there examples of success relevant to you? We've seen lots. I've shown different things that can work. Are there things around that can work for you? Are there examples, importantly, of things where changes weren't measured? And how rigorous is any proof? So the key points that just summarise is that what do you have to start with? Look at the variability in your paddocks and look for key properties and assess your starting point. What might you be able to get to? What do regional levels suggest? What sort of capacity is there for you to get to? Building organic matter and carbon is about getting more inputs, more growth, and less outputs, less mineralisation, loss. The evidence base, there's a strong evidence base of showing historic loss, and that recovery is possible. However, it's not always consistent. It's not always easy or sustained, and doesn't necessarily mean that we're going to get back to where we were. It is harder to build than it is to deplete. And while we have a good, firm, general understanding of the processes, it's how they actually play out in the paddock that's the real important thing. And having some more work and long-term experiments to look at the dynamics and how long changes are sustained is an important thing that we're still doing. If you're looking at a project, you'll see how it fits you. And in any case, you want to be managing nutrition, your productivity, and erosion with the real benefits that we know about from maintaining and cycling of carbon and organic matter. Some of the few studies that have been able to quantify this have sort of point to values of $100 a hectare for having better, higher levels of organic matter in your soil. So that's about it. Future webinars will, as Felicity mentioned, be looking in a bit more detail at some of these things in an area, your starting point, potential, managing constraints and what changes and commitments there are in front of you and what to do with any credits. So that's it from me, Luke, for now.
Thanks, Karl. Fantastic. We've got a couple of questions that have already come in, and I know Felicity's got a few as well. So I suspect you're going to get a fair bit. So I'll go to the questions I've already got typed in. I'll just remind people that you can type your question in to the question pane or raise your hand. So Suze Orgel managed to get in, and Suze, for when you mentioned the results from Canby there, Karl, oh, just by the way, just going to say to Brian Murphy, if you can just, when you're ready to say something, Brian, remember to unmute yourself. Okay, so Suze has asked, and I'll see if you've got a microphone. I know you're on your phone, Suze. When will the next round of Canby data that you reference be available, Karl, do you know?
I say soon. It's coming. It's coming.
Fair enough. It's coming. All right, Suze, you might type in something else if you wanted to follow up there a bit more, Suze. But Diraj from Far North Queensland, one of our regional soil coordinator colleagues, has asked Karl and Brian, how and why does bushfire impact on low carbon?
I might say first, Brian, if it's okay. There'd be a few different processes. Bushfire can sort of burn off organic matter to a depth. Soil's fairly well insulated, but you can have oxidation burning off of the surface material. A big part of the problem, though, is the bare surfaces and the rains that follow fires too often, and just strip that material away. There's cases, there's some studies done up in the Warrumbungles after those severe bushfires, and just sort of showing the mass erosion and losses of material from there.
And did you want to add anything, Brian?
Yeah, I would suggest that generally the soil's fairly doesn't transport heat very well, so there'd be a bit of cooking of the soil, but it wouldn't go very deep. But the main problem is erosion. The bare ground would be the big issue. So erosion would be what would affect the soil organic carbon levels in the soil mostly.
Yeah, good points. Thanks, thanks both. Thanks for your question, Diraj. Kirsty Smith has mentioned, you mentioned to get a ballpark of potential. What's the most practical way for someone to do this at a farm scale or a practical way? Good question.
I think approaching it as part of agronomic testing. Hopefully people are doing agronomic testing of nutrition levels, and carbon can be included, carbon percent can be included as one of those. To get the proper, measure, you need bulk density, and bulk density is a bit of a pain to measure. So it's not done that routinely, but definitely the carbon percent gets you in the ballpark. So if you're sampling carefully and sampling frequently enough, So sampling carefully gives you an understanding of what is where. Look at your paddocks, do that sort of zonal type thing. Break it up into, up, mid, lower. Don't mix up your red soils with your grey soils, that sort of thing. So keep those things separate, and then you'd be able to be consistent with being able to interpret them. Stick carbon on as a measure in your testing, and then the real value in testing is having some numbers, having multiples, either multiples across different paddocks, or even more importantly, timeline. One test now is great. The next one gives you a lot more information, and then the third and the fourth give you more again. So go along, break up your place into what makes sense, and take some measurements on that.
I would suggest, if you're just looking for a scoping,
sorry,
I was just going to say, if you're just into a scoping exercise to see where your carbon's up to, just taking the soil organic carbon percentage gives you a good idea where you're up to, because you can compare what your soil organic carbon percentage is to what you'd expect from, say, some of the land management practices you might want to implement. So if you measure your soil organic carbon percentage and it's down around less than 1, then you've got some room to move to build up your soil carbon. The only caveat I'd mention is, if you're going to do the soil carbon percentage, you must be very careful about making sure you sample 0 to 10. I imagine most people, when they are taking their samples, are careful about depth control, but if you're going to use the soil organic carbon percentage, you must control your depth very well to make sense of the numbers.
Yeah, thanks, Brian. And if for anybody that might not be familiar, the 0 to 10 centimetres of depth we're talking about, Kirsty, I have unmuted you just in case you had, because it's a good question. If you wanted to follow up a little bit, you've got the opportunity, but you're muted, so I'll leave that. Oh, you are. Go, Kirsty.
Yeah, I guess thank you for responding. Yeah, just probably that question around how much potential you have to grow from wherever you already are. So someone might have a really good understanding of their soil carbon levels currently as it stands, 0 to 10s, as you mentioned, and the next question is, well, how much further can we go? And what's the soil capable of? And so is there any sort of way that people can really get that idea based on sort of soil type or whatever? It's probably where the question was going. Thank you.
Yeah, well, I guess that's what I was sort of getting at in the early part of what I was talking about, appreciating what you're sampling, and then looking around for what other comparisons are available. Like Brian said, different land uses. There might be other growers you could talk to. There might be different practices you have yourself. Grower groups, there'd be research around perhaps relevant to your specific area, and that's some of the things that we'll be looking at in future webinars. Maybe not North Queensland, but more locally for us at least. But there'd be work up your way, definitely. I'm sure you could speak to some advisors or researchers, extension people.
I think there's enough data around to know what kinds of values some advisors and other experts would know what levels to expect under different land management practices for different soil types, I would think.
Yeah, I agree, and that's what I was going to say, and Karl said it in his talk. I reckon it's your local data, from as much local data as you can get a seal with Nutrient, Kirsty, and you might already have quite a few soil tests from your own area, and you can compare the same soil type in your area with your climate. So thanks for your question, that's terrific. Cameron Gooley is next, and I have unmuted you, Cameron, but I'll read your question out, and if you want to follow up, you can unmute yourself. So Cameron has said, hi Karl, thanks for the excellent overview. Soil carbon doesn't exist in isolation, and as you mentioned, there are fixed ratios of nitrogen, phosphorus and sulfur. So can we make estimates of the fertiliser requirements and costs to achieve particular target soil carbon levels, recognising also the role of legumes, but higher soil phosphorus requirements and the transient nature of nitrogen cycling?
Yes, and not on the top of my head, but some of the stuff that Helen Coonan looked at there the chart I had earlier with the increasing carbon with P. That was applications there, or 18 kilos of P per hectare per year for 20 years. Built 12 tonnes of carbon. So yeah, those sorts of calculations can be done, and you know, with coming off Clive Kirkby's work there, and yeah, the CNPS ratios are relatively steady like that on the surface. Some of the interesting things that we've seen at depth and out west is lower ratios, actually, sort of around, you know, instead of being 10, 12, maybe like 4, 5, 6. So something different going on with those ones out there. Maybe they're sort of parked at an intermediate level. But yeah, those sort of calculations could be looked at. Just don't have it in front of me, sorry.
So Cameron here. Thanks,
Cam, I want
Karl.
to go.
Yes, thanks. Can people hear me?
Yep.
Okay, great. Look, I just wanted to emphasise that issue that you know, the other nutrients are fundamentally important, and the overarching cost of those, if you have to purchase them in fertilisers, which invariably you do for P and S, and of course for nitrogen, you know, you've got that issue of, well, if you buy it in fertilisers, that's an expensive way of doing it, but then you've got to change your whole land management practices if you're going to rely on legumes to feed that nitrogen into the system. And you made the mention, Karl, of that $100 per hectare was the sort of net benefit for the carbon, the increases in carbon. But I'm just wondering about that, you know, the cost benefit analysis associated with all of those additional soil constraint issues that need to be overcome. Do we have tools and approaches to allow people to actually really investigate those in detail? You know, nobody criticises the need to increase soil carbon, but it worries me somewhat that we're not really getting the full picture in terms of what the overarching costs are associated with building that soil carbon level.
No, that's a really good point, and you know, a whole more presentation in itself, and maybe more than one presentation in itself. Excellent discussion. That number I mentioned of sort of around $100 hectare wasn't so much as here's what you get from rebuilding, but sort of comparisons of out of place, here's how much more productivity there was in these paddocks that had more versus didn't have more. Getting those nutrients back into the system is like the opposite of what we've done. We've mineralized all the organic, sorry, not all, we've mineralized a bunch of organic matter to get the P, S and N out. So yeah, replacing it is obviously where inputs of those are required. It's the sort of part of why I said that sometimes goes up, goes down. That's not a bad thing as long as things are cycling and you've been able to sort of maintain things. Is good. Building is it's a whole nother effort.
Excellent, thank you.
I suggest there's one, Brian here, I suggest that's where, you know, the idea of the old pasture rotation and crop rotation system comes into it. But, you know, you have a period of building up soil organic matter and then perhaps a period where you actually decompose the soil organic matter, which was what used to happen under the old rotation system. But I'm not sure exactly how they would work, but that's sort of what, you know, the rotation system is what you'd be looking at.
But within a soil, okay, I'm sorry, but within a soil carbon project where the objective is to build up soil carbon, that sort of sawtooth approach that you're just talking about, does that fit the objectives of these soil carbon projects?
That's a good question, but I think the thing is, the soil carbon projects are meant to build up soil carbon over the period of 25 to 100 years. So what you do, and you've got a long-term trajectory of building up soil carbon using a rotation system. So rather than, so that's your long-term trajectory. Yeah. So within that system, your soil carbon might go up and down a bit, as I think, as Karl pointed out, the carbon goes up and down because of various, things that happen within the soil. So, yeah. But
I think if you
go on.
I think if you look at the eligible practices, Cameron, they're all basically agronomy. So, liming to overcome constraints, improve productivity is eligible for, if you can measure a carbon increase, then good on you. You measure a carbon increase as well. Yeah, any of those sorts of things. So it's basically sort of sustaining and maintaining, improving productivity where you can. And yeah, if there's an increase, there's an increase that goes with it.
But sorry, just a point of clarification here. So if you are being funded to increase soil carbon in your soil, and you switch from, say, a cropping system to a pasture system, no doubt you'll make a substantial increase in the amount of soil carbon. But then 2 years later, are you allowed to plough that all up and turn that back into a crop again?
Well, that depends on, that's not for, I'm not across that. That's where you'd be talking to your aggregator and reading the rules about whatever. It might be a change in intensity or frequency of cropping, I'm not sure.
But I guess I'm not across that either, but I think one of the things would be you have to standardise exactly at what point in the cycle that you're actually measuring the soil carbon.
Well, yeah. Otherwise, you measure your soil carbon directly before you plough it up. I mean, that's the way to go.
But because of the way cropping, because of the way agricultural systems are, there has to be. I would imagine there has to be allowance that you can have a rotation system within your land management system. Yeah.
So good discussion. Thanks, guys.
Okay. Thanks, Cameron. So we'll move on to Jose Palacios, and Jose has said the creation of soil organic matter from external organic matter inputs is in essence a microbial process. Anything that modifies the microbial activity in soil will affect the soil organic matter genesis. Do you agree? And why is this important factor not mentioned, says Jose?
I think I sort of referred to soil biology throughout as a key step, key part of the process, recycling nutrients, transforming organic matter through. Yeah, they're definitely key to it. They generate it. It's photosynthesis from plants. That's the raw material, and yeah, then there's transformations.
Any comment, Brian, before we move on?
Yeah, move on.
Muted. Yep. Okay, good. Ian Packer. Next, good day, Ian. So Ian said, if you're going into a carbon trading situation, do you need to go to the benchmark sites or randomly take other measurements?
Again, it's a question of detail that is for your partner in the process. There's supposed to be objectivity to it. An area is nominated, called a carbon estimation area. Zones within that are delineated to help, called strata, to help have a bit more consistency of measurement, and then points are sort of generated to go and sample, supposed to be done independently by a third party. There's rules around all that detail about how to go about your sampling process.
Thanks, Ian. This mightn't need to answer this today, Karl, but it's just a question. So Jamie Ingle, who has left, Jamie asked, could you make the presentation slides available to attendees, and said thanks for that, and I'll thank Felicity for replying in the text to everybody, where Felicity has said There will be fact sheets produced to support each of the webinars, and they'll be available on the Soil CRC website and the participating grower group websites in the coming months. And people probably realise they can watch the recording of this. Yes, and thanks. Felicity's also mentioned that the recording of the webinar will be available to attendees. So everybody who's attending today will get an email tomorrow with a link to the recording, and all the people that registered will also get in 24 hours a link to the recording. And you can register after even though the webinar has finished, after today, people can still register. So if you're talking to somebody, they can still register and they will automatically then get the link to the recording. But I don't know whether you wanted to comment, Karl, before we move on.
Yeah, I'm happy to share that if someone likes.
Okie doke. Thanks, Karl. So next is from Michael Gooden, and Michael's asked, if you're entering into a project under the ERF, it's a 25-year project, soil carbon levels need to be maintained or increased over that period. So that looks like I'll take that as a comment, Michael. Thanks for your comment. And Ian Packer has
I think you just get paid.
Sorry.
I think, look, you just get paid if you have your starting point, and if you go up, then you can substantiate an increase, then you can get paid. If you go down, it doesn't necessarily matter. If you go up again, you can get more. At the end of the period, there is the capacity for the government, and you've gone down, there is the capacity to have those credits taken back. And then after 25 years, if that's all you've nominated for, then that's the end of it. Yep.
Thanks, Karl. Excellent. And Ian Packer, who was involved, well, with myself with the Canby project, Ian has, not surprising that Canby showed a decrease when you look at the concept of the project. Did the people who put heaps of inputs to get money from the project continue with them or lost interest? And it might be someone like Warwick Badgery or Aaron to ask that of. I don't know whether you've got any information there, Karl, or not, or Brian.
No, I haven't really kept in contact with it, I confess. Yeah.
Well, those sites were selected as there was a process where people, it was sort of reverse auction. The sites selected had low levels, so they had something to increase from. There's still at least 8 being measured, and as I said, six, they went up after the first one, but 6 have dropped, and there was 2 who maintained it. So that's where we're at.
Thanks very much. We'll move to the last one I've got here is John Lawson, and John has written, assuming a soil carbon project is designed for optimum nutrition and structure, I presume soil structure, what practical soil amendments could be applied to maximise the MAOM and so minimise TOC, total organic carbon loss? Iron, question mark, aluminium, question mark? Do you want me to read the question again?
Yeah.
So what John has said is, assuming a soil carbon project is designed for optimum nutrition and structure, what practical soil amendments could be applied to maximise MAOM and so minimise TOC loss? Iron, question mark, aluminium, question mark.
I don't know about adding iron or aluminium, really. Basically, the MOAM, mineral associated organic matter, is material that is stuck to the side of charged particles in the soil. So the map I showed earlier of John Gray's opportunities, so it was highlighting areas with the material, basically, and people like Elaine Mitchell have pointed to the necessity to target those areas with high clay content and low current saturation as areas of high potential. I know Suze did some work, and if you're there, Suze, you might want to speak to it, that looked at incorporating organic matter to depth and kept finding increases where you're able to get that material right into the clays. The practicalities of that may not be applicable to the field, but having adequate nutrients with it, so rather than just aluminium or iron, having adequate nutrients, as we were discussing with Cameron earlier, that get to those levels where where it gets stabilised would be the thing.
And thanks, Lucas Van Sweeten's added a comment to help there, Karl. So Lucas has written his comment, which lots of research using short-range order minerals, for example, ferrihydrite as soil amendments, not ready yet for field application. Thanks, Lucas. Lucas is one of our soil scientists up in northern New South Wales with a lot of expertise in that field. Lucas, you can let me know if you wanted to make any verbal comment. I'll just take it as your comment from there. That might ask Blake if Blake and Felicity is my backups. Have I missed anything there? A lot of good questions.
All good from what I can see. Luke, just one slipped in. Just another comment from Michael Gooden, which is saying just because you are undertaking it doesn't mean you will be paid anything. If you've been issued ACCUs because you've increased soil carbon greater than any emission or discounts, you can then choose to sell offset or inset. They're very separate things, and that was just a comment.
Yep, it's up to you. Yep.
All right, thanks, Michael, and thanks, Blake. Look, I think we're drawing towards a close. I know that Felicity would like to now just tell us where to from here. So I'm going to take back presentation rights from you, Karl. I'll make myself the presenter, showing my screen. And I want to go to this PowerPoint. Here, I'm hoping people can see. Yep. So I presume this is the screen you'd like, Felicity.
Yes, thank you, Luke.
I'm hoping. Trying to get it into presentation mode while you speak, Felicity.
Thanks, Luke. And I'd just like to say a big thank you to Karl for his excellent presentation, and thank you, Brian, for your answering the questions and supporting this process. And big thanks to you, Luke and Blake, for hosting these webinars on behalf of Soil CRC and PIPAP and the New South Wales Government. It's been a wonderful support, and we've been able to reach a broad audience, which has been fantastic. So the next webinar will be hosted by Holbrook. So like I said, please keep an eye out for the invitation on the Holbrook website and Soil CRC socials. And we'll be taking the next step in, we've looked at the soil data and interpreting that data, and now we'll talk about those soil management practices and opportunities for soil carbon management, and looking at those local farming systems with those 5 farming systems groups. And you'll be able to hear from soil CRC researchers and others in the industry working in this soil carbon space. So I look forward to seeing you all over the coming months as we deliver these webinars for farmers and advisors in New South Wales. And thanks again, Luke.
Thanks, Felicity. Look, we've had one last question come in from Tracy Bird Gardner, and it asks, Tracy's asking, is there a significant difference in soil carbon in heavy vegetation, for example, rainforest to open plains? Anybody like to comment on that?
Yeah, we haven't had much experience with rainforest, I confess, but I suspect the rainforest, because you're in the tropical environment, and probably have a very high biomass input, but you also have a very high decomposition rate. But I suspect it'd be reasonably high under a rainforest, whereas the plains probably not as high as under the rainforest. What do you think, Karl? Yeah.
Yeah, massive difference there, B. You know, enormous difference with the high inputs. A lot of it prone, of course. You know, they do in Brazil is knock those trees over, burn it all, and mineralise it in 3 years, and it's all gone. But to start with, there's a lot there.
Thanks, Tracy. Well, thanks so much, Karl, and everybody, Brian and everybody else, for your inputs today. I'm just going to let people know that our next soils webinar will be from John Friend. It's going to be on soil management after floods. It's going to be on Thursday, the 12th of September at the usual time, 1:30 in the afternoon, Australian Eastern Standard Time. So there's a group of people who've done work following the floods in New South Wales, and John Friend's presenting on behalf of them. So really interesting results and really good study following. As we know, we're all getting quite a few floods these days, and managing soils after it's not the easiest thing in the world. So look, thanks everybody. Another really good webinar, and thanks for attending today. Look forward to the next webinar and recordings and people catching up with them. So I'll call that quits for August, and we'll look forward to seeing you in September. So bye everyone for now.